So, hello again, everyone, and welcome to this workshop on building observable GenAI apps with OpenLLMetry. My name is An Patel, and I'm a software engineer at ShareFile in Raleigh, North Carolina. I'll be your speaker and host for today. So now let's move on to the agenda. So we'll take a look at what exactly it is that we're building. Then we'll look at what is OpenTelemetry, what's OpenLLMetry, and how both of them work together. And we'll actually build something with it to really get hands-on and experience how you can instrument generative AI apps. We'll use Grafana, which is it has a free tier, and it's an open telemetry backend, which lets you push and then view logs, traces, and metrics from any of your services on through their cloud. So yeah, that's what we're going to be doing. And here's a visual of the same thing. We're going to build a service called the arithmetic service. It's a very simple generative AI app because we don't want to necessarily spend a lot of time on engineering the GenAI app. We want to see what exactly it means to instrument it and get those traces and metrics flowing into this open telemetry backend, which is going to be Grafana. So here are the things we will be using today. So we'll be using FastAPI for the service itself to host, to run your server. And we'll be using LangChain to orchestrate the calls to an LLM. You would need access to, I think I missed mentioning this on the event page, but you would need access to the OpenAI API. Let me know in the chat if you don't have access to it, and if you can't set it up. It would ask you for your credit card info. So if you can't, I can DM you a temporary API key, and then I can revoke it after this event. And I trust you that you won't run me bankrupt. Okay, so yeah, this is the app. Let's get into a little more into the weeds of this app. So we're going to create an endpoint on this FastAPI application, and it would have a query parameter where you can pass in the user's prompt. And we'll be just calling this API right through our browser. It would be running on our local machines. So you would literally just open localhost port 8000 and / calculate with some query as a query parameter. And then it would call a LangChain agent, which would orchestrate calls out to the OpenAI API, and then use a few tools that we would have declared. OpenAI supports this thing called tool calling, which means the model, instead of responding with just text, it responds with what tool to choose or execute, and also with the arguments to those tools or that tool. So we'll build that agent, and then we would see how you can observe all of that. Taking one step back, let's see in general what OpenTelemetry is about. So let me share this tab. This is the official page for OpenTelemetry. It's OpenTelemetry.io. So it's just a collection, it's just a bunch of code and standards that people have been using to instrument, generate, collect, and export their telemetry data. Now, what does that mean? So if you ever have worked with microservices or just an API service in general, you would have logs and things like that to kind of be able to debug an application if you run into some errors or issues in production. You want to be able to see what's going on with your application to address those issues. And it could also just be that the app is working as expected, but it's not performing as expected. You can do that kind of debugging as well once you have all of the data about each and every function that your app is calling and how much time it takes to run them. So you can instrument your apps at whatever level of detail you are comfortable with using OpenTelemetry. And the three main concepts that you use to do that, or things that you publish, are metrics, logs, and traces. So your services publish these and they go into an OpenTelemetry backend where you can then analyze those things. So here's what that looks like. For this application, once we have everything wired up, we would be able to see something like this in Grafana, which is what we are going to use as our OpenTelemetry backend for this workshop. So you can see it's creating a full trace. It's like a Gantt chart that shows what all things perspired through the call that went through this service. So the user called this get calculate API endpoint, and then you executed things using LangChain, and you called the OpenAI model. And then finally, you sent back your response. So all of that was instrumented. And then you sent those spans, a trace, back to that backend, Grafana. Here's what it really looks like. Let's see if I can. I see, I was sharing the wrong tab. So this is what it looks like. You have an endpoint that the user called, and then you went into an agent executor workflow on LangChain. Then you called the OpenAI chat API a couple times to get that response and perform whatever tool calls you wanted to perform, and then you finally return the response back to the user via HTTP. So all of that is kind of logged back to this OpenTelemetry server, which is right here. So let me see if I can quickly get a few examples. I think I'm on the free version. So, okay, it does have. So yeah, so you can get all of your traces into an OpenTelemetry backend like Grafana, like you're seeing here. This is the free tier. So we would end up building this by the end of this workshop, and you'd be able to see, hopefully, these traces by the time we are done with this. And if you look into these traces, you would also find that there is much more to it than it looks like on the surface. So if I dive into this OpenAI.chat span, you will see that it has attributes which tell you a lot more about what's going on with this LLM call. What are we sending to the LLM and what it's returning back? And here we are using the streaming API for OpenAI. So it has events as well. And each event was a chunk. So an LLM completion chunk. So you were able to see and track all that through OpenTelemetry. And all of this is made possible by a library called OpenLLMetry, which goes in and puts its probes into all of these things, like the LLM itself, like the LLM client that's a part of the LangChain project, as well as the LangChain agent itself. So OpenLLMetry is just by a single method call, you are able to instrument these apps. So talking about OpenLLMetry, let's take a look at their documentation page. And here's a brief on what it exactly does. So it's basically, it just allows you to start monitoring and pushing out these traces to your OpenTelemetry backend. And it's this simple. So you just import trace loop from their SDK, and then you call the init method with the name of your app. And that's it. Now your app is instrumented, and you can start pushing out these traces to Grafana or whatever backend you are using. You might have New Relic at your workplace or Datadog or something else. So long as it's compatible with this OpenTelemetry standard, you should be good to go. Okay, so now that we know what we are building, let's get ahead and start building it. If you have not cloned this repo, I'll copy paste this link onto our chat. And in the meantime, let me know. I'll pause. If you have any questions, just let me know.
So, question. So, this open telemetry, the data that your application is sending, if you think in terms of enterprise, you don't want to, like, for example, share enterprise IP data. You know what I mean? So,
Right. So for that, OpenLLMetry lets you set certain environment variables that turn the completion and prompt logging off. So you still might want to measure things like, say, the usage of your LLMs per call. How much, on average, in the past week, how many tokens did we use up? And where did those tokens go? Say you have 5 or 6 different endpoints and 5 or 6 different LLM calls as part of each endpoint. So you have different workflows that use generative AI APIs, and you want to measure your cost distribution. So you want to look at how your token costs are distributed across the entire enterprise platform that you've built based on these GenAI APIs. Then you can still use this tooling and figure out all of that,
okay.
as well as things like your latency. Like if you want to see how fast or how slow your app is and how much of a bottleneck these GenAI APIs are, you can make use of this instrumentation to make those decisions.
All right. Thanks.
All right. So, okay. So now we'll be switching over to coding mode. And for that, I'm going to stop sharing. And so we're going to start from scratch. So we're going to make a new directory. Let me share my command prompt window. So this is literally just open up any command prompt. You can use bash, git bash, or depending on your machine, Z shell. You just need to create a directory. Name it anything. I'm just going to go with OpenLLMetry -example, and then cd into it. And then if you have VS Code, just do code space dot, and that should fire up VS Code. And I will need to change the screen share over to VS Code. All right. Okay, hopefully this is, yeah, it looks like it's visible on the screen share. So yeah, blank slate, nothing as yet. And then you can hit control and backtick to open up your command line at the bottom. So once you do that, you will see something like this. And now we can go ahead and start scaffolding this app. So first thing we're going to do is we're going to set up pipenv for this application, for this project. So pipenv is a dependency manager, and it also creates a virtual environment for you so that you can install your dependencies but not spoil your global Python setup. So you can set up all the dependencies you want for this particular project. If you come from the Node.js or C# land, it's like adding a NuGet package or using the NuGet package manager or using the node package manager. So you get a pip file, which as we start adding dependencies here, the list of packages and or dev packages will grow, and the log file just manages the hashes and the whole list of dependencies that you do have installed on the machine, as well as the versions. Okay, so let's start with installing the dependencies we need for this experiment. So we will need quite a few of them. So first, we'll need LangChain, we'll need FastAPI, we'll need OpenTelemetry instrumentation for OpenAI. We will also need trace loop. And let me see if we might need anything else. So we need LangChain. Oh, we also need LangChain OpenAI. OpenAI. And then am I missing anything else? It's actually trace loop SDK. And finally, we would also need OpenTelemetry instrumentation for FastAPI. So, and then just hit enter and you'll see it will start doing its job. And it will get us all of these dependencies. Oh, and yes, if you don't have pipenv, you can just install it by doing pip install pipenv. So I'll type that down in the chat. So if you don't have direct access to the Python pip tool, you might need to do this. Python 3-m pip install pipenv. So that will get you pipenv, and then you would still probably need to do Python 3-m pipenv forever command. So I'll also post that in the chat if you are needing to do Python 3 instead of just pip. Okay, I'll wait for a few. And if you have questions, just unmute and let me know, or type them down in the chat, whichever is your preference. I'll wait for a couple minutes because it might be different for everyone's network to get those dependencies. That's a good question, Ken. So the one reason I didn't go with Langsmith was because it brings you into vendor lock-in. So OpenLLMetry, the only reason we are using it is it's fully open source, and you can just use this to integrate with any OpenTelemetry backend. So you're not tied to one specific platform. Yes, there are a few benefits of using Langsmith, but it's always better to stay open for the tooling you use, because otherwise you never know if they raise the prices and you have nowhere to go. It becomes hard. Okay, I'll wait for 2 more minutes, and just let me know in the chat, or if you're following along and still not installed, just ping in the chat. Oh yeah, sure, Joshua. I'll paste those in the chat. So you need to run get all of these. Thanks for posting the instructions, Ken. Yeah, there are a few more. I think I installed a few more dependencies than I had listed initially on those instructions. I think I had missed the FastAPI instrumentation, but the rest of them should be there. Yeah, so I think it could be used. Not looked into Prometheus, but the only thing I know about Prometheus is it's a time series DB used for telemetry logging. So if it supports the OpenTelemetry protocol, it can be used, so long as it just supports that protocol. Actually, while we are waiting, we can just take a look at. So let me screen share Prometheus. Trying to find that tab. Okay, so this is what I found. So I think Prometheus is a little different, but you can definitely use it with anything, any backend that's compatible with OpenTelemetry Protocol. I think Prometheus has its own set of APIs that you can hit to push your metrics and logs. Yeah, so we are using this approach. So we are using OTLP directly to push these traces, metrics, and logs directly from the app to Grafana. The other approach is to use a collector, run a collector side by side with your app, so that your app doesn't spend cycles on doing this instrumentation itself. So it improves the performance a little bit. Okay, so now let's head back to the app. So we've got the dependencies installed. Now let's try and get the app prototype going. So we'll use Jupyter Notebooks, and if you're new to VS Code, here's a good news for you. VS Code now supports, I think it's been a while, but it supports editing Jupyter Notebooks right inside of the IDE. So you don't have to spin up an instance of Jupyter to play with that notebook. From that, I think we also might need Jupyter here. So let's do pipen install Jupyter. Okay, while that's happening, let's create an empty Python notebook. So right click on new file and just type any name dot. It should end in IPyNB. That's how VS Code knows that it's a Python notebook. And then you will need to point it to the virtual environment that we just created. So without it, if you start typing code here, it would not give you that IntelliSense, not tell you what packages you have available and what's in those packages, because it doesn't know what environment to use. So by default, it's using the global Python environment. We need to point this point this IDE to use the right Python interpreter. So do Control Shift P and it'll bring up this menu. And then just type in Python select interpreter, or you can just type interpreter and it's probably just going to show up. So when you click on it, you will see all the different interpreters and environments that you've created. Ideally, you should see one that was created by pipenv for you. So I have one right here. It's OpenLLMetry example, and then some short code, unique code. That's the environment we needed. So let's pick that. And then now hopefully we should be able to utilize those packages that we just installed. So we would first also need, since we will need to interact with the OpenAI API, there's a package which should be just installed in your, I think I might need to just use the kernel as well. So yeah, you need to click on select kernel as well and then pick the interpreter environment. So it should now be in this state. Let me head back to that video call and wait for any issues or comments. So yeah, let me know if you ran into issues or if you're following along so far. Okay, cool. All right, that's awesome. So yeah, just feel free to unmute if you run into any issues and stop me at any point. So yeah, we have the interpreter selected, and now we should be able to import our libraries. So first off, we need this library called .env. It's just a convenience library that simplifies things for us. So you need to pass the OpenAI API key as an environment variable to this executing Python script. And for that, .env comes in really handy. So what you could do is just have a file in the same folder as your Python script or notebook, name it just .env, and then you can start adding your environment variables here. So first off, we would need the OpenAI API key, and then you would need to go out to the OpenAI API playground or the portal. Let me switch to that screen. So you would need to go to platform.openai.com and you will see this. Let me paste that, and it should be a quick sign up too. So if you are not signed up yet on this platform, you can directly just go to this link and it should take you through the whole sign up process. So yeah, I'll wait for 5 to 10 minutes to make sure everyone's signed up, everyone has their keys. And if you don't want to sign up, let me know and I can trust you and issue you a temporary API key. If you are following along and if you have your API key already, let me know through the chat. So yeah, whatever we are doing today, it shouldn't cost you more than a few cents, at max $1 to do. But they might ask you for your credit card so that you can get that API key and start using their APIs. And if you need help, just let me know. Yes, so Marshall, you will need to go to that project API keys section to get your uh, API key created. So before, you used to have a key for your login itself for your user, but now it's organized by projects. But I think you can still use that old key if you had one lying around. And yeah, once you're good to go, just let me know in the chat. All right, Ken looks like he's got the key. Joshua got the key. Awesome. Okay, no worries, Martian. Let me DM you the a temporary key. Okay, looks like they turned off the DMs, so I'll just directly send this to you. And I'll be sure to delete this once this call's done. Let's see if we can. Set a monthly budget of $10. Yeah, let's do 20. Then at 10, I want to get notified. Cool. Okay. Cool. Joshua, Srinath, Harold, you guys doing good? Joshua's ready. Okay, we still have a couple more minutes. So yeah, once you have your key, okay, so Srinath had an issue with the environment. Okay, cool. Cool. Okay, so let's move to the next step. Sharing my code window again. So now you just need to paste that API key in here. I'll actually just use the same one. Actually, let me just create a new one quickly. So share the screen as I'm doing that. So API keys, and then actually I need to go here, create a new one for this project. So I have my key. Now I'll shift back to the IDE and plop that in. So we now have this key. Once you run load.env now, it should be able to find this key and plop it into OS environments. So anything that looks into environment variables for setting itself up should now be able to see these environment variables. Whatever you put in that .env file should show up. So you would need this key and this value. So OpenAI API key equals whatever key you had. So OpenAI API key equals your key. I put that in the chat as well. Cool. So once you have this key, you will need to head back to that Python notebook and run this. You should just see just true getting printed, which is the return value when this load.env function succeeds. Now you can start importing the libraries we need, and let's just start by instantiating an OpenAI API client, and then let's try calling it. So we'll be using the chat OpenAI interface, and you just need to instantiate it, and it will find the API key from your environment variables and then sign you in. So this should be all you need to get the LLM client spun up. And once you have this, you can make a call to the LLM by doing this. So LLM.invoke, tell me a programming joke or whatever you want to ask of ChatGPT. So once you do that, you'll get back the response from the AI. Sweet. So yeah, let me know with a thumbs up or just anything in the chat so that I know you were able to get this. And I believe we also had this file in the example repository. So let me find that link and post it. So you can directly download this file from GitHub and copy it into your existing folder if you don't want to spend all the time typing this. It's always good practice. So if you had the environment linked up with your notebook, it should be giving you syntax highlighting for the libraries that you import, and all of this code should run. If you did not have it linked up correctly, it might just fail on the first cell. All right. So, Ken, Joshua, you guys, Sahil, you get it working? Let me know if you ran into issues. Can you try using the key I gave Marshall? So just use this key the uh, on the .n file. I think it might just be that it's a new account and they might not have provisioned the resources for you yet. Oh, looks like we do have DMs. Sorry, Sahil, I just saw your message. And I sent you that key as well.
Thank you.
Yeah, let me know once you get it working. You would need an equal sign after OpenAI API key. So it should be OpenAI API key equals, and then the rest of the actual key value. And then you just need to run through these cells.
Yeah, I'm just getting a bit of an error in the second cell.
Okay, can you share your screen? Let me stop sharing mine.
Sure can. All right, can you,
Cool.
can you see my screen?
Yep. So it's showing some error. So it says false when you ran the load.env. Okay, let's see. Up top at the top right, if you click on Python 3.12.4, okay. So did you do pipenv install on this repo?
Yes.
Okay. Can you expand the terminal area? Okay.
Go all the way back up. Hang on. I'm thinking if it goes back that far.
Let's try one thing. Can you open CMD by clicking that plus button? There's an arrow beside the plus button beside PowerShell. see if I can annotate. Yeah, just click the arrow. Instead of the plus button, just click that arrow. So you get to open CMD instead of
Oh,
PowerShell command prompt. So now if you enter pipenv shell, it should create, or if the environment already exists, it should just pop you into the environment. Okay, it says 3.11. Oh, I see. It's a Python issue. So since you are on 3.12, you would need to open pip file. So if you scroll down on that left pane, which has all the files showing up, you'll find pip file, just a file called pip file. Yes. So if you scroll down in that file's contents, you'll see there's a requirement for 3. Just change it to 12 and save it. I've tried this with 3.11. I think 3.12 is breaking FastAPI, but let's see. At least it would let you call OpenAI API. So you'd be able to follow along for the most part. Now, if you try doing the pip and shell again in your terminal, it should let you open that up.
oh, there we go.
Okay. Can you expand that terminal a bit? It's like cutting out the bottom part for me. Thank you. Yeah, it should now just create that environment, and you might need to do pipenv install to make sure the dependencies are in that virtual environment it just created.
And then copy the dependencies that you posted earlier.
No, it's already in the pip file, so you just need to do pipenv install and then hit enter. It should just do it for you. So Marshall, you could, it would just start the app for you, but we are still doing the prototyping. So you can press Control C after clicking on the terminal to exit out of the running app if it did start the app for you. If you didn't have the main.py file, then it would just not start. So you should be fine other ways. Okay, so did it install or is it still installing, Joshua?
Yeah, it's gonna probably take a minute or so. I'll draw my screen back for the minute. Go way down. Oh no, never mind. It's still just. I'll let you know when it finishes.
Cool. Yeah. Okay. Till then, you could keep writing the code, and once it installs, you can try running all of that. So let it run on the side, and you can just follow along in the meantime. Okay. So I shared the wrong window. I think where's the prototype? Okay, this one. Okay. So yeah, we got the LLM to be invoked and it responded. Now we want to prototype an agent that's able to call 401 provided sktemp asterisks. You can find your key at this. Doesn't like the key. Huh. Could you share your screen? Let's see if we can figure it out live. In the meantime, I'll just create another key just in case that one doesn't work. Okay, so I see. Can you print out, if you can create another cell above and just print out os.getEnv? So yeah, in that cell, or yeah, after it, just print os dot, I think it's get environment. Let me look that up. Okay, it's just os.getEnv, and then it's a method call. So you will have to do the parentheses after the getEnv. Not there, but after getEnv. So getEnv is just one keyword or identifier, and then the circular ones. So yeah, perfect. That should print out the key. Oh yeah, you would also need to do the OpenAI in as a string. So OpenAI _ API, all caps, key, and it should be like a string. So you'll need to cover it up with like single quotes. OpenAI _ API _ key. Yeah, that should, if you run it now, it should print out. Okay, let me check if that matches the whole string. Actually, you missed a few characters after the LM. So it doesn't end with an M at the end. If you triple click on it, it will let you select the whole message. Just triple click real fast. So if you open the tab, the chat tab, and triple click on it, it would give you the whole message. While Ken's getting the key to work, Sahil, you can share your screen and we can try to figure that out.
Sure. Hold on, I think it says I'm not allowed to share the screen. Hold on.
Oh. It shows you as a presenter. So it might be a permissions thing on your PC. On my end, it just shows you should be able to screen share if you want to.
Yeah, I don't know what's going on, but so for me, on the right-hand side where we select the kernel, right?
Yep.
I can't, it doesn't create a new Python environment for me for creating, that one.
Okay, so what happens if you do pip and shell in your command line here? Do you see an environment on the left of the prompt?
Yeah. Yes.
Okay. So what you can do is just do Control-Shift-P and then click Select Interpreter, and then let me know if it shows up with the same name on your screen. If it does not, we can enter the path manually as well.
No, it doesn't come up. So I already had some Honda environments. They show up, but this one doesn't.
Okay, interesting. So what you could do is you can click on Enter Interpreter Path,
Mhm.
and then click on Find, and then you should have a directory. Like if you go to your, let me share that screen. Which window was I sharing? Yeah, I might have to share. Okay. Is it showing the window? No, it probably isn't. Let me see if I can just share the whole thing. Entire screen, share. Oh, wow. Okay. Yeah, so you go to your user if you're using Windows, and then backslash, and then go to .virtual env under your user folder. So that should have all the virtual environments that got created. One of them would be your example environment.
Oh,
And
okay.
once you're
I'm on a Mac, but hold on.
oh, cool. Awesome. So Ken's got it working. Yeah, for Macs, we might be able to. We might have to do a little bit of playing around because I've not had much experience on Macs.
Yeah, I'll try to find out. We can go ahead.
Okay.
Thanks.
Cool. So now, since we have our LLM client working, we can now go ahead and try to create an agent which would call whatever tool you are, whatever tools you want it to be able to call. So it's called a tool calling agent, and in LangChain, let me open up my code window first. Okay. So yeah, we're going to create a tool calling agent. It's going to be a very simple one. The only thing it does is schedules an operation, add, subtract, multiply, or divide, one of those four, and then determines if it needs to schedule any more of those operations to get to the answer that the user had wanted. So the user just passes, this is the app we are trying to build. The user passes in some textual expression, with the LLM should be able to figure out what methods to call to evaluate that expression from plain text. So let's start. Let me open up the documentation for a tool calling agent. So screen share. Okay. So it's pretty simple. You can specify a bunch of tools in a list of tools, and then you pass them to this helper method that lets you create an agent. And then there's this concept of an agent executor that actually takes the actions that the agent schedules and runs them, like calls the tools. for you. So, or for the agent. So the agent itself, it can only schedule one task at a time. And the agent executor is an abstraction that calls the agent itself numerous times. You can set a limit. You can set a limit of, say, 15 tries. So it would do whatever the agent asks of it for 15 times max. The agent might decide one of three things. One is, I'm done doing my job. The answer is complete. Or the agent might decide, okay, I need to call some tool. And the third one is just, oh, I crapped out, something went wrong, just error out and stop whatever we are doing. So in that case, you return some error response. So those are the only three things the agent can do at a higher level. And the agent executor does whatever the agent tells it to do for under specific constraints that you can set. So what we'll do here is create an agent that can call four tools, one of four tools. So let's get at it. Let me share the code window. And so we need this helper method as well as the agent executor. And then this function as well, which you will get to see why we need this function imported as well. Other than that, we need chat prompt template, which is an abstraction that lets you create just templates of a sequence of messages, which you can then interpolate with whatever variables that you pass into that prompt. So in LangChain, everything is kind of you can call it like a callable, like a function. Everything is a runnable in LangChain. So if you want to create a sequence of steps for calling a large language model and doing something with the response, in LangChain, you create a chain. And then it starts with some input, does some processing, calls out a model like chat OpenAI, and then gets back the response, processes it a little more, and then sends the response back as the response of the chain itself. So that's a chain, and everything that constitutes a chain at a higher level is just a runnable, including a chat prompt template or an agent executor. All of them implement this runnable interface, so you can kind of chain them together however you want to. But what we are going to do is just first define the tools and then pass them to create our tool calling agent, and finally create the agent itself by utilizing agent executor as the wrapper for the tool calling agent that we create. So, all right, let's create the tools first. And here's where the tool function comes in handy. So in Python, you can also use these decorators. And it is a handy way to create these tool objects. So you don't have to, use some constructor and pass in arguments to create a tool abstraction or tool object to pass to the tool calling agent factory method. You just need to use this decorator, and you can create as many tools as you want or declare as many tools as you want, then pass them when you actually go in to create that agent. So it's really simple. It's literally, this is our first tool. It's the add tool. And to give more information to the LLM, you can just write a comment here. like this. And then do the same for other ones. So we'll do subtract, and Copilot is already catching on to this. And divide. So we got all these 4 tools. And I'll wait for a bit so that everyone has these down. I'll also paste them in the chat. Yank it. Okay, so I just pasted it. You can copy those from the chat if you want. And also I'll also get the import lines. Cool. So once you have these tools, next step is to create the agent itself. So I think, was it tool calling or was it create tool calling? Yeah, it was create tool calling agent, not tool calling agent. Okay, so once you call that, you need to pass the LLM. You also need to pass the tools. So let's just create a list of all the tools and then pass them here like so. And then you also need to pass in a prompt template, which is, it should follow a certain format here for the tool calling agent. So that format is that your prompt template should have a variable in place for the agent's scratchpad. It's like the agent's temporary memory for it to plan things out and execute them. So for that, you just need to do this. You need to create this chat prompt template from a list of messages. And this would be, we would need to provide the AI with some context as to what task this agent is solving. So So let me paste this prompt, or you can copy it from the GitHub. Doesn't really matter how you frame this because it's such a simple problem that this LLM anyways figures it out. Plus, whatever tools you pass in, they are passed separately as part of a separate field instead of just the messages strings. So the tools are passed separately to the OpenAI API. They have support, special support for calling tools, which is what this tool calling agent abstraction leverages for you without you having to do any of that coding yourself. So this is the prompt I'm using currently. You can write your own. This is the system prompt. That's the first message in our chat prompt template. It doesn't have any variables, but the next one would. So the next one is we need the user's input. So it should be human and then user prompt. So this is a variable that we are referencing here. So when you invoke this agent, you would have to pass this as part of a dictionary that constitutes the input to our chain. In the meantime, I think I had a few more variables that were needed. So you need we also need to pass in a placeholder message for the chat history. So placeholders, there are mainly four kinds of messages uh, in LangChain. So first is a system message, then you can have a placeholder message, you can have a human message, and then you can have an AI message as well. But we don't need that. We just need system, human, and then another placeholder. So what a placeholder message is that okay. So what a placeholder message is there's a few bikes going out uh, inside my apartment, so it might be a little loud. Let me mute for a second. Yeah, it looks like there's a huge motorcade and it's probably not going to stop. So let's continue. So the agent scratchpad is, wait, we were talking about placeholders. So a placeholder, it's just, it replaces this chat history variable as a list of messages. So it expects chat history to be a list of messages, which it will plop into this existing list when calling your model. So every time the agent takes some steps, that gets added to your chat history, which the agent executor manages. And then when it invokes the agent again, it passes the chat history in. It's the same with the agent scratchpad. So whatever the agent, the agent scratchpad is used by the agent, and the chat history is used by the agent executor to manage the full interaction with the agent, interaction history. So yeah, you need this prompt template, and you need to pass that into the factory method call to get the agent initialized. Once you have the agent, you just need to pass it into your agent executor like so. And then you also need to pass in your tools. So this, and then optionally, you can mark verbose equals true so that you can see what's going on with your agent. So this is all of the code that you need to create that agent for yourself. I'll paste this whole cell into the chat. Okay, it's not letting me send that in the chat because it's larger than, that's weird. Let me just try to send the last part. Okay, this one went through. So once you have those tools created, you can use this piece of code to create your agent. And once you have the agent executor created, you should be able to call it. Let's first try running this and see if we get any errors. And we do. Okay, so we missed a comma. Cool. Okay, so once this is done, you should be able to invoke with, you have to pass in the user prompt as part of the of a dictionary, so that gets replaced here in the human message, And once you run this, it should technically evaluate, call the tool. As you see here, it invokes the add tool with these arguments, and it got back 5. And this is in green is the answer from the AI model. So you get that back here. Let's give it a little harder task, which you would not expect out of the box model to be able to solve. So let's give it this, and it should solve that correctly, and it does. So yeah, out of the box, the AI might not be able to do this. So let's try the same thing here. It might not be able to get you the exact answer. Looks like it did here, but let's complicate this a little more. Okay, I have no way to test this unless I go out to, yep, it got it wrong. So the actual value is 134, but it got this wrong. Let's try asking, and I have no idea because these explanations for each tool might not be prompt engineered and tuned the right way. We have not done enough testing on this agent to call it stable, but here goes nothing. Let's see if it works or not. I need to copy that again. So in this case, it has to use the BODMAS rule to evaluate or figure out what order it needs to evaluate things in. Let's see what it comes up with. Okay, looks like it messed it up. Let's see if we can try to nudge it in the right direction a little. Okay. Cool. It got the answer, but it has it wrong. Let's see what it tried to do. So it multiplied. Did I change it? No, it's the same. So 22 plus this. Okay, that's good. Oh, it's actually correct. This one's wrong. Let me try plopping this into a calculator again. I'm getting 134.67 on Google. Seems to have done the right thing. It scheduled the multiplication. It got this number back. It invoked the add. It got this back. I see. It messed up the last step. Did not use this from its history to do the subtraction, but instead relied on this other number to perform that calculation. Let's see if we can tweak the prompt a little bit. Okay, I gave it a little more pep talk on the system prompt. Let's see if it does a better job. Cool, yeah, and it does. So this time it used the right values to get to the exact answer. So it's 134.6725 here, and it is also the same on Google. There it is. So cool. We've got the thing working, and now let's look at the chat and see what's going on. Cool. Joshua got it working. Okay. Yeah, Marshall, that is expected because we turned the verbose mode on. So it will let you know what's going on in the agent itself. This is just for development. So if I go back to the code window, you'll see we set verbose equals true. What that does is it just turns all the logging on, gives you more logs than you need, than you would ever need to debug your code. So yeah, and that's what you are seeing here as well. It's the full log of the agent, but I think it's formatted differently, might be formatted differently because I'm viewing it in a notebook as opposed to just viewing it in the terminal. So yeah, I think that might just be the difference, but so long as you're getting the answer, it should be fine. Let me paste that prompt, final prompt template, if you're not getting the answer you are expecting. Cool. So yeah, that's the answer. And we are almost through with the whole GenAI prototyping phase, because this was the last cell for this prototyping phase. Now that you've experimented with your GenAI app inside of a notebook, you think it's stable enough, you played around with it a bit. Now you want to actually create an API out of this app. So for that, you need to use FastAPI or any other framework that lets you create an API out of this. For Python, FastAPI is pretty easy to use, so we are going with that. Just create a main.py file in that project directory. The code after executor. Okay, let me see if I can share that part. So the code after getting the executor created, it's really simple. It's just invoking it by passing in a dictionary with just one key, user_prompt. And it maps that input to this message in your prompt template. Cool. So yeah, we have this agent now. So we can start scaffolding out the API now. Unless if you have any questions, I'm looking at the chat right now. Let me know if you need a little more time to get this executor to work. Awesome. Joshua, you're able to follow along so far?
Yeah, I was able to follow along. I'm a little bit behind, but yeah, I'm tracking pretty good.
Gotcha. Cool. All right, looks like Ken also got it working. Okay, so we can now move on to the next phase, which is actually creating that API. And this one's, it's really simple to spin up an API with FastAPI. So all you need to do is just create a Python script file, it's main.py, and then import FastAPI. So we already have it installed, so you should see this. If you don't see the syntax highlighting, it means that you're not selected the interpreter for the virtual environment. So you need to pick the right interpreter from here, and once you have that selected, you should see it getting highlighted just like you would on your Python notebook. Since it's in the same directory, if you set the interpreter once, it should just be there. But just in case, you can just do Command-Shift-P or Control-Shift-P, and then just search for interpreter, and you'll find this option to select the interpreter. And then once you pick it up, you should be able to see this. Once you do this, you get access to our installed libraries. Let's quickly create a FastAPI app. It's this simple, and then you can do app.get. Let's create an endpoint called calculate, and it will have let's do this. And so now we need to actually create our agent first, but let's just do like a hello world to start with. Let's see if our API is able to be spun up and gets us some response. So let's just say we just report back that our service is running. Once you have this saved, I'll paste this in the chat as well. Once you have this code saved, you should just be able to run it by going to your terminal and then typing in pipenn run uvcorn main, which lets you refer to this main script, main.py, and then you need to pass a reference to the app instance that you created here, which is just called app. So you just do main:app, and then you can optionally specify a port. If you don't, I think it defaults to 8000 anyways, but you can do this -- port equals 8000. And then if you wanted to hot reload, if you change the main.py script, it just reloads the server, starts using the latest script. You could just do -- reload, and it should spin up the app and will get you the service. It will get the service running for you. So once you are here, it will, let me open that. Okay, so you can just go to any browser window and do localhost :8000/calculate, and it will show you, not this one, it's an old, yeah, it will show you this message. If I can paste that URL. All right. Yeah, looks like Marshall, you've got the app set up correctly and it's running. So yeah, it's all good. Yeah, so once you have that app running, you can just click on this or open localhost :8000/calculate. on your browser, and it should just send a request to that server you created, and that should let you access the API and get the response back. So you should see arithmetic service is running or something of that sort, whatever you wrote in it. And you'll even see that in the logs. As you make those requests, they will get logged on your terminal. Yeah, sure. Let me switch over to the terminal. Okay. Yeah. So I just did pipenv run. Let me paste this. Cool. Yeah, so the hello world message in the original main.py, I had it on the, I believe, just a slash endpoint. So you don't need to enter any path. As soon as you go to localhost :8000 without the slash calculate, it will just show you hello world. So PrettyPrint, it's just a plugin I believe I'm using, or maybe now they have that functionality built into Chrome. So the format that of the response that you're seeing here, it's called JSON, JavaScript Object Notation. And the PrettyPrint, just as soon as you click on that, it will let you, oh, I'm not sharing that tab, am I? It will just let you see. So it will just format that for you. It's just the same contents, but just makes it easier to see. It's a browser level thing. It doesn't change the response one bit. It just formats it so that you can read it more clearly. Cool. All right. So once you have this service running, just type anything in the chat. So I think Marshall has it. Let me know, Joshua can. And I think that we are kind of like on time. It's 8:51. So let's get the service working with the agent itself. And then we should probably schedule another session, maybe next week, to actually get the OpenTelemetry setup done, because it involves creating a free account on Grafana, getting those environment variables, pasting them into the .env file, and adding a bit more code to this API. So let's get the agent working today. Cool. So the next step is to create another module or just a Python file. Call it agent.py or executor.py. And you basically just need to bring over the code that we already spent time articulating. So paste that in here. And you would also need the code that you wrote for instantiating your OpenAI client. You would need that here. So the file should look something like this. Once you have the agent executor created, it's time to invoke that executor. So all you need to do here is change this to just call the agent executor. So you can say response and then executor. You will need to import that from agent import executor, then you invoke it with the prompt. So that's it. Just this one-liner on the main.py side, but on the agent side, there's a bunch of code that you have to write. It's all the same code that we wrote. So from all of the tool declarations, you can just get all of that and the imports from there. And then you would also need to create the OpenAI client. So it's just these two lines: import chat OpenAI and then call that constructor to get the client instance. Cool. Thanks for hanging out with us, Srinath. Hope to see you in future sessions. Have a good night and weekend. Yes, Muktesh, I think I already have that code on GitHub. Let me paste that link. So it's at this link. And we'll also be recording this. So this would be like a part 1, and then we'll do a part 2 probably next weekend, same time, Saturday, 7 p.m. And we'll get the OpenLLMetry stuff set up. So this is the agent. We have the agent created. Let's see what happens if we invoke it. So the code in main.py, Ken, is, let me paste that in the chat. Yeah, so you just need to import that executor and then get the, oh, I see. When I paste things into the chat, it seems that it's forgetting about all the new lines that I had in there. So that's a little inconvenient, but yeah, you would need to import the executor from that agent file module, and then just call invoke as we did on the notebook. So that's a good question, Marshall. So add tool, just basically it declares the function that you write after doing add tool as a tool. So it's called a decorator in Python. It's a feature, it's a native feature to Python, decorators. What decorator functions let you do is whatever function that you declare here, that whole function is treated as an object and it's passed into this tool, which is itself a function. So if you hover over it, it will show you that tool itself starts with, it mentions that tool is a function, and then it has takes a few arguments, and these arguments are compatible with the decorator API that's standard with Python. It lets you use it basically lets you wrap a function to do things with it. In this case, we are just adding some metadata that LangChain needs by doing this. And then when you create a list of these methods, all of these or functions, all of these are just objects. Python just treats functions as objects, and you can put them in a list like we did here, and they have some extra metadata thanks to the add tool decoration that we did on top of each of them. So they are now treated as LangChain tools, and then you can pass them in wherever you need a list of tools in LangChain. So it's a LangChain function that who built LangChain wrote, that takes a function that you create and mints out a LangChain compatible quote unquote tool that you can use with all of your LangChains, tool calling agent, and other stuff that works with tools. Okay, so once you have this API set up, you might need to also import the .env code that was up here in main.py. But I think I have a feeling FastAPI already does it for you. So let's just keep it as is and try to invoke the calculate API. Okay, let me share my screen. Okay, so by default, since we defaulted the prompt to what is 2 plus 2 in the code, it treated that as the prompt. And then the output is that the answer is 4. So that's the response from the agent.invoke call. This whole dictionary it resulted from the agent.invoke or executor.invoke. And it's nested inside of this response field that we had declared in the handler method for this calculate path. So yeah, this gets you the answer to what is 2 plus 2, and then you can also play around with it. Like, just be wary that in a URL, in the address bar, you probably won't be able to easily add the mathematical signs. You can get around that by just saying words instead of writing those special characters which get encoded as something else. So here I did what is 2 plus 2, plus being not the mathematical operator, but the literal word plus, and it still worked. So yeah. Okay, so cool. Can you share your screen, Ken? Let's see what's wrong with the setup there. Oh yeah, definitely, Marshall. We'll be posting this on YouTube. So yeah, for sure. So Ken, you will need to create a new file in that same folder alongside main.py. So you would have to right click on the LangChain OpenLLMetry example folder that you created, and then click new file, and then do agent.py. And hit enter. And in this file, you would have to paste most of the code. Oh, you had it. Okay, I see. You might be just able to drag it on top of the new file that you created. So like click on the older file that you had. Oh, this also works. Perfect. So that should give you that agent. The YouTube channel, I believe, is just GDG Chapel Hill. Let's see if I can pull up that channel. YouTube GDG Chapel Hill. All right, I just pasted that in the chat. Okay, let me head back to the code window. Cool. So yeah, we have this executor.invoke. So you might have a little bit of a different code, Ken, in case you ported the agent file from the original project. So you might have to look for what is the name of the variable we gave to whatever resulted from this agent executor instantiation. So you would have to import that over here. So yeah, but there you have it. That's the API, and to integrate it with OpenTelemetry, let's do another session. And for that, it would be great if you can set up a free account on Grafana. So let me quickly show that how you can get a free account on Grafana. Let me share my screen. Okay, so if you just Google Grafana sign up, you would see the first link here takes you to the sign up. So for free, you get all of these things, 50 gigabytes of trace data. All of this stuff comes for free, and it also comes with 14 days of retention. So all of your trace, whatever is sent to Grafana, it stays in your account. You can access that up to 14 days, and then it will just vanish. But anything new you send it will still have that, and that will get retained for 14 days from the point you sent that data in. So this is more than enough for what we are trying to do. And all you need to do is just click on Google and get the account created. It's completely free. Once you have that, you would be taken to the dashboard, and then you need to do a little bit of some setup, which is really easy. So yeah, once you have that created, we should be able to quickly instrument the app and see those traces flowing into Grafana.